Okay, going the other way. Use the properties of logarithms to condense each logarithmic expression. Write the expression as a single logarithm whose coefficient is 1. Where possible, evaluate logarithmic expressions without a calculator. So condensing. So it's still going to be my 3 new properties that we had today, but going quote unquote backwards. That we want to condense things. So we want to go from something bigger to smaller. Bigger to smaller. So if I have the addition of 2 logarithms going backwards, I can rewrite that as 1 logarithm, but the logarithm of a product. If I have subtraction of 2 logarithms, I can rewrite that as 1 logarithm, but make a fraction or a quotient of the arguments. Now, something to note on both of these that kind of put logs together, adding, put the 2 logs together into a logarithm of a product, multiply the arguments. Subtracting, put them together, make the arguments into a fraction. Both of these rules that put logs together do not have coefficients in front of the logarithm. That's just log log. Same thing here, not log log. It's not 2 log base b or 4 log base b. No coefficients. The rule that's going to help me do coefficients down here is the power rule. And again, going backwards, that if I have a coefficient out in front of the logarithm, that coefficient can pop up and become an exponent on just the argument. And so in order to use these 2 rules that actually put logs together, when coefficients are involved, I'm going to have to use the power rule first, because these rules up here do not involve coefficients. And so if I have a coefficient, the rule I'm going to use first is my power rule. So there we go. I have to start with the coefficients. So I start here with these coefficients. Start with coefficients. And the power rule, quote unquote backwards, tells me that the coefficients can become, I really do feel sorry for you guys having to read my handwriting, can become exponents. And so this becomes log x squared plus log y cubed. Now I have addition. So here, addition product rule backwards, addition can be put together, by multiplying the arguments. And so this becomes log of x squared y cubed. The parentheses there are somewhat optional. And so we have condensed that. That's what they wanted. Okay, doing a similar thing. Starting generally with coefficients. Down here, we're going to have to do a little bit here because of these parentheses, but I don't have any parentheses involving, there's some parentheses here just grouping the argument together. But it kind of ignoring those guys, I don't have parentheses, so I'm just going to start with the coefficients. So again, doing the product rule or power rule first. Backwards. Coefficients can become exponents. So this becomes natural log of x to the 5th minus natural log of x plus 3 to the 4th. And now I have subtraction. So that is the quotient rule. Backwards. Subtraction can be put together by dividing the arguments. So this becomes natural log of x to the 5th over x plus 3 to the 4th. And there we've done the problem. That they just wanted us to condense those guys, and we've condensed them. Again. Now you got a couple things you can do here, a couple ways to get through it, but I think I'll start inside, sort of inside my parentheses, and sort of not. Well, that didn't make much sense, but I'm going to start with the 3 and the 5 there. And so we'll do the power rule backwards. And I've already written out twice what that means. The power rule backwards, coefficients can become exponents. So we'll say 1/2 log base b of x plus log base b of y to the 5th minus log base b of z cubed. Now let's work inside the parentheses there. That 1/2. So then the product rule backwards. And it's written up there, product rule backwards. We can put things together by multiplying. I'm going to have to write a little smaller here. Product rule backwards. We can put things together by multiplying the arguments. Then let's do that guy. So another power rule backwards, and I don't really have room to write down power rule backwards, so I'll say it. Power rule backwards, and that 1/2 can go up and become an exponent. Then lastly, looking at that minus sign, quotient rule backwards, and again, I'm running out of room. I should have put this on another piece of paper, but running out of room, so I won't write it, but I'll say it. Quotient rule backwards, and it's still right up here. Quotient rule backwards, subtraction can be put together by dividing the arguments. So this becomes log base b of xy to the 5th to the 1/2 over z cubed. And there you've done the problem, but I am willing to bet that if you type in that answer, the computer's going to mark it wrong. And here would be a perfect example of something the computer might mark wrong that I feel is just perfectly fine. The reason why I think the computer's going to mark this wrong is that most of us would prefer to look at that exponent of 1/2. Instead of looking at that exponent of 1/2, most of us would think it looks prettier written this way, that an exponent of 1/2 is the same thing as a square root. And that's what I think the computer would probably want. Now, like I said, to me, both those answers are perfectly equivalent, and for me, they're both perfectly acceptable. You condense the logarithm, that's what the instructions said. But I wouldn't be surprised if the computer went to the square root. So this would be an example. If it went to the square root and you didn't want to do the whole problem again, you just write me and say, on problem 12, I didn't go to a square root, the computer did, and I can adjust your score. But there we've put those guys together. Okay, one last condensing problem. And I did this one because when I was looking at the problems in your homework, There's one in your homework that is almost identical to this. And so since it's in the homework and I didn't want to have to answer it, however many students I have in college algebra, I decided to do one in class and then warn you, there's one in your homework like this, so pay attention here. There is one small trick we need to do on this one. And this is why I'm doing it, so that when you come to your homework and you see one that's like it, you too can do the one small trick to get this guy started nicely. And the one small trick is right here, that from these two last terms, I'm going to factor out a negative. And so then this becomes 4 log y plus log y minus 5. And that's going to make the problem so much easier, pulling that one little trick of pulling out that negative, so that I only have to deal with a negative and making the fractions, because none of us like fractions. At least that's been my history, that students particularly don't like fractions. If we want to avoid fractions as much as possible, and the way we put subtraction back together is to make fractions, if I want to try to avoid as many fractions as possible, it'd be nice just to have a single minus sign there. So I'm going to take out that minus. And then I will start with that exponent right there, or not that exponent, that coefficient. And like we've said a couple times, coefficients can go up and become exponents. Then we'll do each one of these each one of those additions. Additions can be put together by multiplication. So that's going to be log of y times y squared minus 25 minus log of y to the 4th times y minus 5. Addition, product roll backwards. Addition can be put together by making a product. Now, just having to deal with that one minus sign, quotient roll backwards, we can put subtraction together by making a fraction. And there we have condensed as much as possible, but again, anticipating like I said, there is a problem like this in the homework on the computer. So if there were students in the classroom where I'm teaching, I would cover all that up and I said, what do your instincts tell you to do? And someone would eventually answer, well, my instincts tell me to factor y squared minus 25. So we will do that. That's a difference of squares. And so there we have it factored. Then I'd say the next same thing. What do your instincts tell you to do now? And so, generally I'm greeted by a lot of silence, but someone would eventually say, cancel? And indeed, I can cancel. Or the more precise term, divide. Y divided into y to the 4th would be y cubed. And then the y minus 5s cancel. And there, make that look prettier. The y and the y to the 4th cancel, leaving y cubed. And so my final answer, y plus 5 over y cubed. And there would be the absolute perfect answer. Nothing else cancels there. Remember, you can't cancel in the phrase for canceling in a fraction is to factor and cancel like we did here, or cancel from all the terms or none of the terms. And since I can't cancel anything from that 5, I'm not going to cancel. Okay, we'll end this video, and then we have one short little thing to do in the next video, but I can't get it done in 30 seconds, so end this video and then a short video for the rest of this section.